Okay, in this math 2, we're going to do 95, 96, 97, and 99 from chapter 2. A couple of these will be really fast. A couple of them are going to take a little while, so we'll figure it out. The laser light is pointed in the mirror at the as shown at the right. So you have a mirror, right, which is this one right here. There's a laser light. It's pointing at the mirror, and then it hits the mirror. You have a little bit of a reflection, and then eventually pops back out again. Or the light bounces off the mirror, comes back out. If angle x measures 48, what are the measures of x, of y, and z? So if x is 48 degrees, okay, so here we go, 48 degrees. So we have a vertical angle, x and this one right here are going to be vertical to each other, so that means y is also 48 degrees. And then because you're looking in the mirror, this angle here, this 48 degree angle, is actually going to be reflected in angle z. So this is going to be 48 degrees also, right? So all three of them are going to end up being 48 degrees. Justify your reasoning. X and y are vertical angles. That's why that works out so well. And then y and z are actually reflected angles. So think of it as just y is actually reflected across your mirror, right? Because the mirror is a reflection. Y and z are reflections of each other. So they're both going to be the same also. All right, 96. Are the triangles at the right similar? If so, write a flowchart, proof to justify your conclusion. If not, explain how you know. Yes, they are. And it's actually the same as the homework that you just did last night. So I'm going to mark the angles that are the same, because obviously we both see that the 90-degree angles in both. Okay, and you actually you don't know that A and D are the same. I don't care what you want to tell me. B, D, and D, E don't have any parallel markings on them, so you can't say that those are the same. But I do know, or the picture, we do know that this angle, angle C, is going to help us out. And here's how this is going to get done. We have two triangles, technically. All right. This is B. This is going to be B. Okay. This is A, this is D, and angle C is the reason why it's going to help us out, is because technically angle C is angle C for both of them. Oh, this is E, my bad, not B. Okay, but C is the same angle for both triangles. So we have this one and we have that one. Okay, and technically all we need is two angles to show that two triangles are congruent, because to show two triangles are similar, because the third one will automatically be the same if you know two of them are the same, or two pairs are the same. So technically we do have an angle-angle similarity, and we're going to do a flowchart for it real quick. It shouldn't be too much of a hassle. We don't have any numbers, right? So we can ignore the top stuff. Okay, and then I'm going to go straight to angle B, right? So we have angle B is congruent to angle E. Oh, we do have numbers, right? Angle B equals 90 degrees. Angle E is equal to 90 degrees. Those are givens. We have B is congruent to E, definition of congruence. We don't have anything for angle C. There's no numbers there. So we have, okay, this is going to suck, but you can't say angle C is congruent to angle C. Your ACB, so angle ACB is congruent to angle DCE. And this was given. No, it wasn't given. Shoot, it was not given to you. What do we want to call that? Technically, it's reflexive property. It's congruent to itself. I feel like this is wrong somehow. I'm going to have to look this up. I'm going to put a question mark next to this. Okay, and then that's it. We're done. You only need two angles, right? And you have both angles, and you're good to go. So angle-angle similarity, and triangle something, something, something is similar to triangle something, something, something. Please make sure it's the similar symbol in the middle and not the congruent symbol, right? Okay, 97. here we go. Write an exponential function that passes through the points 0, 32, and 3 and 4. Okay, well, I'm going to make a table because 0, 32, 1, 2, 3, 4. Okay, we have, and then 3 is at 4, and that's all we know. Okay, I guess we don't really need 4. So, let's see. We have going once, going twice, going 3 times. So the question is, what do we multiply 32 by? 1, 2, 3 times to get to 4. Okay, well, we could try some things. Let's see. What do we multiply 32 by to get to 4? So 32 times 1, 32 times 2 is going to be 64. We're going the wrong way. 32 times 1 is just going to be 32. If I just keep doing times 1, I'm just going to keep on getting 32s, 32s, 32s. So it has to be a number less than 1. It has to be a decimal. So let's try halfway between 0 and 1, and then we can narrow it down from there. So 32 times 0.5, that gives me a 16. Okay, let's try this 2 more times, right? Times 0.5 is an 8, times 0.5 is a 4. Okay, so I did it 3 times, which is what I needed, and I ended up with a 4 on the 3rd time, so that's good to go. So 0.5, 0.5, 0.5. So this was 16, that was 8, and then that was 4. All right, so your equation is going to be y equals, your starting value is wherever the 0 is at. So it's going to be 32, and in parentheses is what you multiplied, 0.5, to the x power. There's your exponential. And if you were to graph this really quickly, it would look like 0 and, I don't know, 0, let's just say that's 32, like that. It would look like this. Okay. It would start with 0, 32 is your y-intercept, and then it would just keep on going down and in that direction. Okay, number 99. Renee has programmed her music player to play 5 songs or playlists in random order without repeat songs. What is the probability that the first song is a country song? Okay, well, I don't know. 2 out of... She's got 2 country songs, and she's got 5 songs without repeating songs. Okay, and she's got a playlist of 5. Okay, well, 2 of these things are country, so that's pretty much just going to be 2 out of 5, because I don't see any more countries. Okay, next one. If the first song is a country song, does that affect the probability that the second song is a country song? Yes, it does. All right, so in your first pick, you have a 2 out of 5 chance that you're going to get a country song. All right, but your second pick, let's say on your first pick you did take a country song. It came up with country, I Love My Mama, right? But now on your next pick, you don't have 2 country songs to select anymore, and you can't repeat. So you only have 1 country song left, right? And then out of the 5 that you've already used, you already took 1 out. So technically you're left with 4 songs to pick on your second pick, because you only have 1 country song left and you only have 4 songs left to choose from. So it's not 2 out of 5 on your second pick. It's just 1 out of 4. So you only have 1 country left, 1 country song left, and you have 4 songs total. So that was different than, your first. You had 2 songs out of 5 songs total. Okay. Part B. As songs are playing, the number of songs left to play decreases. Okay, that's true. Therefore, right, because it decreases in terms of, you saw that right here. If you had 5 songs, if you choose one already, 4 songs is what you had left. It decreased. Therefore, the probability of playing each of the remaining songs depends on which songs have played before it. Okay, this is an example of events that are called not independent. If Renee has already listened to Don't Call Me Mama, Carefree Blue, and Smashing Lollipops, what is the probability that one of the singers of the 4th song will be Sapphire? Explain your reasoning. Okay, so she's already picked. She's already listened to Don't Call Me Mama, so I'm going to cross Don't Call Me Mama off the list, or I'm going to put a little dot next to it. She's already listened to Carefree and Blue, okay, that one's good to go, and Smashing Lollipops, which is this bottom one right here.